Hello, welcome to Point On Studio. My name is Young Park, and today I'm going to show how we can create analytical model using Rhino Inside for Revit, and later on we'll continue to calculate the analytical model with SOFiSTiK grasshopper components, because SOFiSTiK grasshopper components also support Rhino Inside. Last time I showed how we can actually use imported CAD file in Rhino to organize it as an analytical model with grasshopper, and then we could calculate the model in SOFiSTiK. And today it's going to be even more exciting because Rhino Inside is a complete game changer. So I guess it's really good for Autodesk. It's a win-win, both Autodesk and McNeil associate, because I think both softwares are sort of heavily rely on both design and engineering industry, and I think this step with Rhino 7 is really good compromise between the software, and especially Autodesk Revit didn't improve much in terms of sort of dynamic or design parametric design tools. Of course there is Dynamo, but Dynamo engine is too slow, and the geometrical operation is not as good as Grasshopper. So I'm very excited, and let's have a look together what brings new possibility with Rhino Inside with Revit. Alright, here I prepared the file that is really simple geometry with slabs, foundation and floor slabs, and some columns and all. We have some openings, and then yeah, it's supposed to be lift overrun, but I just draw it without any sort of realistic dimensions. But nevertheless, we can use this tool model, and when you go to add-in, we can click on Rhino inside of Revit, and it will bring you to the new plugin for Revit. Takes a bit of time. Alright, it brought the new interface under Rhino's, and just make sure before using it, you have to make sure your unit, project unit in Revit, if that is what you desire. For me, I would like to use meters for the structural calculation, especially with the Rhino Inside, so I set it meter unit. And now if I go and open Grasshopper, and this grasshopper is popping up inside of Revit, which is really good. And what is interesting is that when you look at your task manager, if you look at the software list, only Revit is appearing, and Rhino is not appearing, because actually Rhino is running inside of Revit. That's the reason why the memory is using only the Revit at the moment, which is also interesting. And another thing is, it's maybe difficult to have use it with only single monitor, because you know you need to have Grasshopper window, Rhino window, and also Revit window on the same system. So which means when you have just one single monitor, sometimes it's just difficult to browse between the platform. So I would recommend at least 2 monitors to use it, or if you have 3 monitors, even better. So I have 3 monitors if you look at the photos here, which is handy. Alright, so let's get started. I'm going to open Rhino also, so you can have a look Rhino interface. Let me organize a bit for the tutorial. So Grasshopper help here, and then Rhino Inside here. a bit and make it perspective view a bit bigger. So that's how I can imagine to work with it. I don't even need layers here because I'm gonna work only with the grasshopper. Alright, so I'm going to open this example file I prepared, and it's gonna be it's not that complicated, so hopefully you can pick it up quickly. So I put this extra plugin so we can also see the component's name. So first of all, in Revit, of course you can enable your analytical model, so you can, you know, already for instance, if I go and click enable my analytical model, then you can see there is analytical model, but it's really unlikely we'll get good analytical model out of Revit physical model, because there's junctions and sometimes nodes are not connected automatically, so there's a lot of tedious work you have to organize your analytical model. I hope in the future Autodesk update this analytical model function, because it's been, I don't know, last 10 years never updated, so it's kind of stupid. Say stupid is sorry, but it's kind of like it's out of update, let's say. So I hope this analytical model function Autodesk updated in the future, because it's been for a while without any update, at least last 5 to 10 years, and it's a little bit out of date. So hopefully we can get better sort of performance or different features of analytical model in Revit. But for now we're not gonna use analytical model from Revit. So I'm gonna open Grasshopper, and in this script here I use here query categories from Rhino Inside component on the Revit, and on the category we have query categories, and here we're gonna use Rhino's Grasshopper's ordinary input filter mask to connect, because this query categories is taking all the information of Revit category from open project file. And here I have marked floors and wall, structural floor, columns, all the main structural element. I marked it. You can hold your control key and then you can mark more area if you wish, something like that. But at the moment I just marked it only structural element that I can turn on and off the analytical properties. So that filter mask I'm going to filter with element category filter, and then from document elements, because this filtered thing is going to use this document element, so this filtered element going to be converted to elements in Rhino Inside. These elements now we could control like we can extract the parameters, or we can also set new parameters. So if I put the right grasshopper panel, you will be able to see what kind of Revit elements we are taking out. So right now we're taking all wall structural components from this element category filter, and I'm shooting this to set element parameter. And what I want to do is actually I want to use this enable analytical model parameter, which you can find it in Revit. Let me go here. If you click any structural element on the structural, you can see here enable analytical model. You can tick or untick. So when I tick, it automatically goes back to untick, because my Rhino Inside is controlling this property. So make sure this is case sensitive, and this system parameter has to be exact pair. So if you use another language of Revit, for example Korean or German Revit, then you have to write here correct parameter name according to your language package. So if I toggle this value to true, then let me see if, as you can see, all the analytical model, they are they are appearing in this view. And of course we could use filter to create new filter, so we can have connect analytical model, unconnect. I'll put it okay for now, and we can also add so let's make some more filter. So I'm going to connected one, I'm going to duplicate it. So say here connection state equals to auto detect. Let's put manual. So here I rename it to analytical node manual, so we can see if it's manually connected or not. And here connected analytical nodes, I'll rename this to automatic. Just type auto, some name. So I'll make it equals to auto detect, and this unconnect I leave it as equals to unconnect. So I'm gonna add one more thing, manual here. Then we have here manual, auto, and unconnected ones, and I can change the color of this filter to red, which is not connected, and if it's manually connected, I'll leave it to blue, and auto connected one, I'll make it to like bright green. So when I have a look, as you can see, all of them automatic connected, and where the openings area is not automatic connected because there is no connection, and some columns, as you can see, they are not connected to the floor, or you can see here this edge is not connecting to the wall edge. Of course we can always adjust this position of analytical model manually. Then once you connect manually, you may be able to see the blue points that indicating manually connect node information. So right now it's both of them automatic connect, that's why it's green. But as you can see, when we want to manually adjust this analytical model, it could be really tedious. Like luckily it works well, but sometimes it's really annoying. So I wouldn't recommend to manually modify this analytical model unless Autodesk updated in the future. I wish they do really work on it, but other than that, I wouldn't recommend to do these things. So what I'll do now, in Rhino Inside, I'll turn it off. So we'll turn off all the property from here and recompute. So as just refreshing your computation from Rhino Inside, so we have all analytical model is turned off from your view. But now we're going to use this physical model of Revit elements in Rhino Inside to convert them to be able to use as an analytical model. So the script here I wrote, let me go here. So we gonna use world system family from Rhino Inside here on the Revit, and when you go on the input, we have this components world system family, and we're going to query all the world, and using this filter, element filter, we're going to specify specific type. That's also again nice thing about Revit, because we can pick the type of element from current project. Because if you look at this file here, I named the type as external wall 200mm, and when wall is interior wall, then it's called in with a prefix and 200mm. That's why we can filter with Rhino Inside. So far it's more or less same as Dynamo, but the Rhino Inside is amazing because we can use really a lot of third-party plugins, and today we're going to show SOFiSTiK connection with that. So I'm going to query filter all the words from here. Let me recompute. And first of all, let me turn off all SOFiSTiK plugin part. I'll disable it. So back to grasshopper, we have now, I filtered it, and then I'm dispatching between exterior wall and interior wall, as you can see. So we have exterior and interior wall, and that now from exterior wall, I'm going to analyze the wall property using Rhino Inside for Revit. There's a component called Analyze Wall Location Curve. So from there, I'm going to use center curve of the wall, which is, you can see if I go wall geometry, and when I connect both components, you can see from center line of the wall, I can extract the bottom center line of each wall components. And then this one, I'm going to split the list so I can get the foundation level and all the other levels. It's a bit, yeah, and because the reason why I want to connect the edge of analytical surface with this analytical line together. So I did some offset operation here. So these curves are now offset towards the exterior side of the wall, and also at the same time this edge is going to meet with Revit's let me turn on Revit. So if I go free wireframe, the preview doesn't show here, right? Because I use this the graphic settings, but basically this, I'm pushing the edge of this wall, the center line of the wall towards the edge of the analytical surface of the floor. Alright? Okay. And then I offset the value, and from the wall that we exterior wall, the geometry we have, I'm analyze whole wall because I want to know the height of this wall, these walls, and then we can operate a little bit of data structure to extrude the modified curve to generate as an analytical surface, right? And then I call some index to define two different sides, and the same operation goes to the interior wall here. So at the moment, these extrusion of analytical surface, they are perfectly connect each other but without any openings. So far we are doing wall operation, and then I'm going to create now the openings. So I merge all this, extract all the data from interior and exterior wall, analytical walls, that we merge into merge component, which I can now make an additional operation. So what I'll do here, we have this one more time, I'm picking up the door opening, the family type, because here when you look, these openings are actually the one of the door type, and this filtered type filter will convert again to elements. So we now, the Rhino Inside understand this Revit type family in Rhino Inside system with grasshopper, and we'll get head height of this door. So if you click on the door, you can see here we have head heights as a instance parameter in Revit that we could extract in Rhino Inside, and we can organize the list. And here we have element location, so all these doors we pick from Revit, we can hook the output to input of element location, then it will give you the work plane of the points and as well as all other like element information. And here I'm just deconstruct the plane from here. So we have the center point of the plane where I can put the cutting box shape which we can operate with this surface. So we can actually subtract this volume of box to make opening out of this surface, right? So I did this operation here, and we basically some minor the components to extract the opening surface. So we have only the subtracted surface here, and that we can always use both. If it's with a grasshopper component, we can use it if sometimes we want to calculate without openings, or sometimes you want to calculate with more openings. So that preview show here, if I turn it off, that's how I operate extract or analytical surface out of wall components from Revit. And flow is even simpler because we're gonna use document category picker component, and we're going to take all the floors from Revit, and then we'll use element category filter. Again, now we're going to use document elements, and then directly these elements we're going to convert to grasshopper, Rhino and grasshopper. So these now convert to preview of grasshopper. So we have these are foundation slab and floor slabs. They all now appear in Revit. In Rhino, which is, if you can see here. So it's a bit difficult to do with one window, so let me minimize the Rhino. So we have 400mm foundation and 300mm generic floors up to there. And if you now go to Rhino Inside, we have these slabs and foundation slab below. So this geometry from element geometry, now we can do normal grasshopper operation. So I deconstruct rewrap from them, and then I organize a little bit of data structure, and we connect the lines to be able to to create single surface, and that this single surface I want to position it either center of the floor. So last video you can check from above link that shows the sort of similar script, so you can actually convert between top of the floor or bottom of the floor for this result. But let's leave it for center for now, center position. And that result, if you look, then these are all centralized. If I turn on this preview, they are center of the slab and foundation slab thickness, and which is good because they are connect to the analytical surface of the wall, perfectly match. And now the column is also simple. We use document category filter picker, use and drop down menu we specify as structural column, and same step we use element category filter and then document element. And I'm going to here use from this element column, and I'm going to get element parameter called base level. So if you look at Revit, when you click on column from the instance parameter, you can see base level as an instance parameter. This is Revit system parameter, so it's always there, but just be careful when you use another language of Revit software that this system parameter is translated into each languages. So it's not always working if you put just base level string here. And then I just create a set and delete consecutive elements, and then from that list I'll filter the level, and we have like the curve pattern with these filtered information, because it will give boolean output, true or false. And for that I can filter with a curve pattern, and then eventually I can create the element. So if you look here, that's the column from level 1, level 2, level 3 and 4 and so on. So these columns, now I can, because these are just the solid build-up, and eventually we need to extract the analytical line of the column. So here now I just do normal operation. For me, column is better to operate from per level to level, because I don't need to create complex the data structure script in sort of components in Grasshopper. So here I can deconstruct, and then again same operation. We get the area, and from the minimum area, and we get the center point, and then we connect as a line, and we evaluate curve from center point. We can stretch it, so we can, if I compare here with slab, so when these scaled lines, they're going to meet to the floor, then we can get the intersection points that we can shatter, and then we're going to dispatch, and we can get the straight column, either straight. If there's a slanted column, you can also get the slanted column data, but right now there's no slanted column for level 1. That's the reason why all the other components are giving warning, because there is no more input. But if you go to level 2, I put on purpose here one slanted column. So this column is also appearing from this tree here. So we have these components are activated. So in this case, level 2, we get straight column and slanted column that you can highlight now. And the we need to, because this is elongated columns, so we need to split, shatter the line based on the intersection point. So for that, we find the closest point, and then remove duplicate points, and we connect these points to the line. Then we have eventually the correct analytical column of the geometry, right? I think it's nothing special. So you see, and I highlighted all the nodes and as a green with a custom color component, and as you can see now we have perfect analytical model out of Revit geometry. So all these things, now it becomes even special, because we can now use SOFiSTiK plugin. So I'm going to enable this, and yeah, enable that, and you can calculate now this analytical model out of Revit in SSD. So it takes a bit of time, because I just enabled the component, and my computer is calculating the load cases. So we have here a bit of wind load, and then I gave dead load for whole structure, so the self-weight dead load. So let's have a look in SSD. So SSD now opens here. It's just same step. So we have here dead load, which shows is here in this structure, and we have here windrow. So windrow shows from this direction there, so we can calculate. And what is nice is we are using grasshopper, so it means now we don't have to manually modify analytical model anymore. So let me go back to Revit. I'm gonna minimize this, and for a moment I'm going to disable the text file synchronize component for SOFiSTiK. And what I'll do, actually, I'm going to, let me disable entire SOFiSTiK part here. So let's modify some geometry from Revit, and let's see how these script behave. So I'm gonna minimize. Imagine you may have another door, or I don't know, maybe some irregular pattern of openings. So I move here, and let's move this window door here, and that another position. Maybe I'll copy here here in another position, maybe move it a bit, and let's just randomize. Of course, this thing, everything we can do now with Rhino Inside parametrically, but for now I'm just doing it manually how I want it. So just move it around, and maybe this is very regular openings here, so I move it here in this position some point, and of course I shouldn't hit the column, and move it here a bit. So let's make it here also irregular patterns, random patterns, do it here, something like that. The interesting thing is your so your grasshopper is update simultaneously what is given from Revit, because we are keep referencing Revit element with Rhino Inside, which is super cool. I think it's like the whole history of Revit going to change because of Rhino Inside. It's a really game changer, and I'm not sure what Dynamo gonna do. I mean, there are a lot of things you can still do with Dynamo, but yeah, the Dynamo packages, they are kind of, it's open source, so it's nice, but yeah, the grasshopper is much mature in my opinion, and the data structure and the performance, everything is much faster in my opinion. So now I'm very curious what Dynamo development going to be. There should be some sort of differentiation, but yeah, I think for a while I will use only Rhino Inside for Revit for now. Alright, so I'll just copy some doors, and you know, let's move some position of the column. Of course this is gonna be a bit funny, but you know, in reality, yeah, why not, we can do it whatever we like. It's not a real project, so I just put some steps out away, you know, make it fun, interesting structure. These two, I'll move it away, and perhaps these two to this pattern I'll move it a bit, and that one I'll move it, push a bit closer to there. So now accordingly our structure should be updated from, sorry, the analytical line should be also updated. So sometimes it doesn't show here, that is funny, but then sometimes you may have to recompute. So recompute means Rhino and Revit, they are synchronized sort of data in between. So you can see here now everything is sort of up to date, and there is slanted column. Of course I did it on purpose to show the script from my grasshopper. I can also move it further, or maybe you can change the slope angle So if it's out of the tolerance, then we have to increase the tolerance, but from the script. But when it's within the tolerance, then when I recompute, then the elongated line should, okay, so maybe it's really still out of the tolerance. Let me, that's funny. Yeah, recompute. Let me go to grasshopper and Rhino. Oh, okay, so the slanted one I can check here. Column parameters, and that increasing, yeah, when I increase this tolerance, so they are matching to this between the slab. Of course, I can also change the orientation a bit in Revit. So let's see how it behave. So here from the floor plan would be nicer. So in Level 2 floor plan, I'm gonna move this, rotate it a bit, the position of it. So like, let's say about that. Then in 3D view, you can see it still follow that axis of the column. So super nice. I really like it. So now we have this sort of modified structure. Then I'm going to enable the SOFiSTiK part. And as you can see, that sorry, excuse me, the dead load, so the self weight and the wind load is applied. So let's have a look the SOFiSTiK part of it. So in SOFiSTiK we have this analytical model final result from grasshopper. They are hooked up to, for example, foundation slab, and we have now floor slabs, and exterior and interior wall. I merged them together and gave them same property, so it's just wall. And then we have here columns and wind load. I gave this extract the wall from the grasshopper. So let's have a look. So these two wall side, and here I want to apply wind load. So let's imagine wind direction comes from there. Of course, we can always change the vector of the wind, so it depends, we can change it like that. So these load and support we don't need for now, because I gave foundation slab. If you look at SSD third material, I gave the bedding option, and here in the bedding it's automatically applied to the as a area support. Alright, so these are all organized, and all these components now going to be assembled on the SOFI mesh component, and the mesh density I can change. Right now, if you look at the density is about 2.4 meter, but I can make it a bit, let's make it bigger, maybe make it smaller, like 1.1 meter mesh density. And here I'm applying dead load. Dead load ID number is 1, and then the wind load I gave ID number of 2, so which means load case 2, and then the type is not, and the dead load we going to give factor of 1, and the other load I'm going to give 0, and then we define the title of the load, and we combine this load case attribute to SOFI load, and then eventually we're going to hook up all this data, which output data, to a text file. So the text file, now I just enabled it, which means it's automatically synchronized from this exist file path. And when I go to SOFiSTiK, all I need to do is synchronize, calculate this grasshopper input, then it will recalculate the current text output from grasshopper. And now I'm going to calculate the linear analysis, so we can have a look the adopted result. So it's calculating the output. So let's have a look. So you see the whole structure is updated from Revit, which is super nice. I mean, obviously we could manually change analytical model from Revit, but that takes a lot of time if you involved in continuous amendment of your concept structure. Then it's gonna be nightmare to always modify the analytical model. So let's have a look now. That road, it shows that road, and when I click on the wind road, you can see the whole structure is based on the wind road it affect. So I think that's all in this video. It looks quite interesting. Actually it's very simple. So we just need to reference with Rhino Inside the native Revit components. These components does everything automatically. You don't even need to write any code. But what is nice about is that you could also use the programming like a C# or Python that you can access to now both Revit and Rhino, the API documents, which is very interesting. I'm still learning all the API and programming, but I would like to one day I would like to show some development from my side. So anyway, so this all Rhino Inside part is done, and then you need pure grasshopper operation to extract analytical models. This is like a basic grasshopper. So if you practice enough for the data structure, then you can, I think you can make better, shorter and even nicer script than what I did here. And eventually all this organized grasshopper output, they're going to be connected to awesome SOFiSTiK plugins. So the SOFiSTiK is very simple. Just define the material and thickness of the structural area, and we can choose the member if it's column or beam, and then hook up them all up together. And now here in grasshopper components, you can just define the load case from grasshopper, and then we can finally we can sort of synchronize the teddy file to central data bank in SOFiSTiK. Then your job is done. So you don't need to work too hard during the concept stage. I mean, not only concept stage, you can change it as well in the future for realistic workflow. So my opinion is that it's very important to know new technology, of course, and at the same time architects and structural engineer, they should work really together. Otherwise our industry have a lot of wasting of hours of coordination. I wish this video brings you some sort of new thoughts, new idea. And if you like the video, please subscribe me. That way you can support my channel to continue more interesting research, and also like the video, and if you can share it, even better. So thank you guys for watching it, and I wish you have a nice time with this new workflow. Bye bye.